Hello and welcome to the Thermochemistry Calculating Delta H quick podcast. Now I have an individual podcast for each one of these items on how to calculate delta H, but I just wanted a general checklist of different methods that you could use, sort of to give you an outline of how you would know which ones you would need. So these would be the 5 ways to calculate delta H. There actually is a 6th way that you're going to be able to use in our next section of this unit, where you can use Gibbs free energy, but that's a really different type of calculation, so I didn't include it here. All of these are basically thermochemistry ways to be able to calculate it. So the first way is to use calorimetry. So when you use calorimetry, you're going to use Q. So you're going to say Q equals m dot c dot delta T. And you're going to use the calorimetry setup where you've got the two styrofoam cups, and you've got your lid. I want to draw a lid here, and you measure the heat transfer. So that's one way that you can calculate it. And there's an entire video on that. The second way to calculate it is going to be to use Hess's law. And all that Hess's law basically says is that if you have a series of reactions and you can add them up to equal your desired reaction, all of the delta H values add up to the total reaction. So for this one, you'll have a list of ones like A plus B gives you C, and C can break down into D plus E. And so if your desired reaction, if the reaction you're trying to solve for is, let's say, A plus B goes to D plus E, well, you can take the delta H1 value and the delta H2 values, and, oops, we can't see them because they're off of the screen. Well, that's a delta H. And you can add the two of these up, and that will equal this one. Now, if one of these had been flipped, you can flip it around, and you can watch the entire Hess's law video on that. So that one, you're going to have a series of reactions. You're going to have to add it up to be yours. The heat of fusion and the heat of vaporization is going to basically be based on the state of matter, or the energy graph that looks like this, where you heat something up and then it turns into a liquid, and then you have melting, you have freezing, you have boiling, etc. like that. And I'm kind of writing all over the top of these. Let me change colors so you can kind of sort of see. Let's see, what color have I not used yet? And so fusion is going to be the energy that it takes to melt something. So the energy required to melt something. So if you had something that then froze the opposite direction, you would have the same amount of energy, except for instead of needing to put the energy in, it being endothermic, right? It would release that amount of heat energy. Vaporization is going from a liquid to a gas, or boiling. And it would be the same way. If you have to put energy into it, it would be a positive delta H, and if it was going the opposite way, so it was condensing, it would release that much heat energy. To calculate the fusion and the vaporization, you would need to be given specific values, delta H per mole. And then you could just multiply each one of these values by what you have. The delta H for vaporization for a substance, and every substance has a different one, is going to be much higher. So for every substance, it's going to be much higher to turn something into a gas than just to melt something, because you have to actually, for vaporization, for boiling something, you actually have to break those intermolecular forces. With fusion, you just have to weaken them enough so that the molecules or the atoms can start to move around. Okay, and there's an entire video on that. The next one is the heat of fusion, and is the heat of formation. And with this one, you'll be given a list of tables. And these two, 4 and 5, are frequently confused. The heat of formation is the amount of energy it takes to form a compound. So with the heat of formation, all elements, even diatomic elements, will be equal to 0. And all you basically need to do for this is add up your products and subtract them from your reactants, which is exactly what you're also going to do with number 5. So for both of these, you're going to do the sum of delta H. Whoops. What does that sound? Oops. Let's try that again. Of delta H products minus the sum of delta H reactants. And that will give you your delta H for the entire reaction. With the heat of formation, it's just entirely already as compounds. With the bond energies, you have to take each molecule apart. You have to find out how many bonds are in it. So each one of these, numbers 1, 2, 3, 4, and 5, each have their own videos. But I just wanted to outline with you, if it says calculate delta H given this information, you may have to sift through. Sometimes they'll ask you to calculate it multiple ways. So they'll give you a heat of formation, and then they'll also give you Hess's law, and they'll ask you to compare them. And most of the times you'll get very, very similar numbers, not exactly the same because there's rounding errors and such. Or you could compare the value you get for calorimetry versus how much you should have gotten based on the fusion and vaporization, any different makeup of those. Okay, so go back and watch each of the individual 5 videos, and that should help you with actually solving the problems.